Okay, so say we have the curve L, which has a parametric form, which means that every point on the curve is expressed in some third variable named t here. So we're tasked with finding the implicit form. Now what you have to do for this is you have to solve the resultant. So I'll walk you through it. So the first thing we have to do is we have to write both these equations as polynomials in t. So we'll just rewrite it like that, and then form the polynomial in t. Now the next thing we have to do is we have to look at the degrees of this polynomial, of these polynomials. We see that this polynomial has degree 2, and so has this. So their total degree is 4. That's going to be the dimensions of the matrix that we're going to form. So their total degree is 4, which means our matrix is going to be 4 by 4. All we have to do now is plug in some entries into this matrix. Each row is going to consist of the coefficients of this polynomial. So we can see here the coefficients are negative x, 1, and negative x again. So that's what we're going to plug in the first row. And if we run out of coefficients, we just put 0. Now each following row, we're going to shift the coefficients by 1 to the right. So I've done that here. So we have 0, and then negative x, 1, negative x. The only question that remains is for how many rows do we have to shift? For that we just have to look at the degrees again. So for the polynomial in x, we're going to have as many rows as the degree of the polynomial for y. So we're going to see that this polynomial has degree 2, right, for y. So we have to do 2 rows in x. Same thing for y. We're going to plug in the coefficients. Each row is shifted to the right. And we do that 2 times because the polynomial for x has degree 2. So for example, if this polynomial had degree 3, we would have 3 rows for coefficients for x. And all that remains now is we just take the determinant, we plug it into Wolfram alpha or something, and set it to 0, and then this is going to be the implicit form for the curve.